In this video, we are going to review finding the greatest common factor, which we commonly call the GCF. First, let's define our greatest common factor. The greatest common factor of two numbers is the biggest integer that can divide both numbers without leaving a remainder. Remember, integer is your whole numbers, so 0, 1, 2, 3, 4, 5, and then they're negatives, -1, -2, -3, -4, -5. So no fraction pieces, no decimals. There are multiple ways to find a greatest common factor. We're just going to look at one of the ways in this video, but if you know a different way, feel free to use it. This is what our problems will look like, and you don't need to write down this example. I just wanted to start with one that was already worked. Finding the greatest common factor of 12 and 16. So the first thing we do is list our factors of 12. Remember, those are the numbers that multiply to 12. Remember, they always come in pairs, so 1 and 12, 2 and 6, 3 and 4. And then factors of 16, 1 and 16, 2 and 8, 4 and 4, since 16 is a perfect square. To find the greatest common factor, first we look at the common factors, the ones that are in both lists, and then we look for the biggest one. So our greatest common factor between 12 and 16 is 4. Now, let's use this process to find our greatest common factor from each pair of monomials. And in fact, I can just say constants, since these don't have any variables with them. So first I'm going to list my factors of 6, and I just start at 1 and I keep going. 2 goes into 6, 3 goes into 6, 4 does not, 5 does not, and 6 goes into 6. Done with that list. 39, 1. It's not even, so 2 doesn't go into it. 3 does. 4 doesn't. 5, 6, 7, 8, 9, 10. I'm just going through the list. 11. 12 doesn't, 13 does, because if I do 39 divided by 3, it gives me 13. Once I have a pair, I know the next one's going to be a pair as well. So my only common is 1. 1 is common with everything, and 3. So between 6 and 39, my greatest common factor is 3. Okay, let's do the same process for 40 and 10. So my factors for 10, 1, 2, 5, and 10. And I know I'm fast at that. It might take you a little longer. My factors for 40, I'm just starting at 1 and going. So 1, 2, 3 doesn't go, 4 does, 5 does, 6 does not, 7 does not, 8 does. And see, I've got a pair there. So 4 and 10. I'm going to keep going, but I'm going to show you a little trick. 2 and 20, and 1 and 40. Once you get to this 10, you know none of the bigger numbers are going to work. So my GCF here is 10. Now if you looked at that and said, well, 10 goes into 40, so 10 is my greatest common factor, that's fine too. You don't have to show me all of this. Now, the monomials we're going to be dealing with are going to contain variables. This is a very important note, so let's make sure this gets written in your notebook. When the monomials contain variables, we're always going to use the smallest exponent for each variable. So let's look at some examples of that. So here we have 18g squared and 27g cubed. The first thing I'm going to do is look at the 18 and the 27. I'm going to do that before I think about my variables. So my factors for 18, 1, 2, 3 goes, 3 times 6. 4 does not go, 5 does not go, so 3 times 6, and then I can do my pairs from there. 6 times 9, and 1 times 18. And then my factors for 27. 1 goes. It is not even, so 2 does not. 3 does. 4 does not. 5 does not. 6 does not. 7. 8, 9, and since it's 3 times 9, I know I can go to 1 times 27, because they always occur in pairs. Perfect squares, the middle one forms a pair with itself. Now my biggest common one here is 3. So the first part of my GCF is 3. Now, the g's are common, so I'm going to have a g, an exponent of 2, an exponent of 3. I'm going to do the smallest, so 3g squared. Okay, on example 4, I'm going to kind of cheat a little bit. Not really cheat, I'm just not going to show all my work. I notice right away that 15 goes into 45. 45 divided by 15 is 3. So my GCF is going to start with a 15. I could list my factors, but since 45 is divisible by 15, 15 is going to be my greatest common factor. Again, the g's are common, so I'm going to have a g. I've got an exponent of 4 and an exponent of 3. I pick my smaller exponent. We're going to look at 2 more examples. Okay, 16 and 9. So let's start with our smaller number, 9. We've got 1, 3, and 9. 16, we've got 1, 2, 4, 8, and 16. Again, I know I'm fast at that. You'll get better at it. My only common factor is 1. So my GCF is going to start with a 1. Now, I look at my variables, a squared and then b. A is not common, b is not common. So that's my GCF. It's just 1. My greatest common factor there is 1. Okay, example 6, starting with my 9 and my 30. Some of you can look at that and you can immediately see what your GCF is, and that is fine. Do that. If not, you're going to list it. So 1, 2, 3 goes, 4 does not, 5 does, and it's 5 times 6, so 3 times 10, 2 times 15, and 1 times 30. And it looks like my common factor there, my GCF is 3. So I'm going to start with the 3. Then I have a and a, so the a is common. I've got an exponent of 1 or an exponent of 2, so I'm going to keep an exponent of 1. The b is not common. The c is not common. So my GCF is 3a. That is how we find our greatest common factor. You're going to complete your practice problems, and this is a very important skill as we begin our factoring of polynomials.